Hello, my name is Adam Chong,
Hi, I'm Jen Damalon.
and we're going to be talking about the SIR model. So, what is the SIR model? It's a mathematical model originally used to study the spread of disease. Using information about a disease and a population of people, it predicts the number of people infected over time. There are many variations on this model, and while the model has its roots in epidemiology, it can be used in any kind of process that occurs over time. For example, the spread of information, a computer virus, or the reaction from a crowd. The population being analyzed is separated into three groups: those who aren't sick and are at risk of catching the disease, those who are sick and contagious, and those who have recovered and become immune to the disease. More formally, the groups are susceptible, infected, and recovered, which is what the SIR stands for. Susceptible people become infected, and infected people become recovered. The total population remains the same unless births and deaths are being considered. To observe the change in the population, a function over time is made for each group. The rate of change of the groups are directly related. Because susceptible people become infected, the number of susceptible people decreases as the number of infected people increases. Similarly, the number of infected people decreases as the number of recovered people increases. This means the derivatives of the equation representing each group are related to each other. This makes them a system of ordinary differential equations because an ordinary differential equation is one that includes derivatives and functions of one variable, in this case time. One variation of the model is the SIRS model, where recovered people can become susceptible. This can be used for diseases where immunity is lost over time. Another variation is the SEIR model, where an exposed group who are not contagious is added. Susceptible people become exposed, and exposed people become infected. SEIRS also includes recovered people becoming susceptible as well.
Now we know that the SIR model can model and simulate disease spread throughout a population. Can this be applied to a zombie outbreak? It turns out that yes, we can. There is one such variant of the SIR model called the Susceptible Zombie Removed, or the SZR model. It takes into account the property of a zombie disease where the dead or removed population can reanimate to live as a zombie. Mathematically, this can be represented as a transition between the removed and zombie population. In this diagram, we can see that there is a modified SZR model with vital dynamics. We can see that a reanimation rate is added between the Z and R population. Like the SIR model, we can further modify the SZR model to better fit the outbreak scenario. We can add a latent rate, which adds an infected but not zombified population. This is known as the SIZR model. There can be a quarantine population of zombies and infected people who are laid to rest and put into the removed population. This is known as the SIZQR model, as shown on the right. Like the SIR model, we can add a treatment rate that can convert zombies back into humans. And one further modification is performing impulsive attacks against zombies, which would drastically reduce the population in a short time. For more detail about the SIR model, check out the credit source for these slides. The SIR model is not limited only in theory, it has real-world applications. It has modeled various real-world outbreaks in various systems outside the field of epidemiology. It has its uses in modeling networks, informatics, and economics and finance. Some real-world outbreak examples are the 2014 Ebola outbreak in West Africa and the dengue fever. Dengue fever is an interesting example, as mosquitoes are the primary disease vector, and is modeled with the SI, or susceptible and infected model. People infected by the dengue fever are modeled by the SIR model. Interestingly, while the SIR model has its roots in epidemiology, it can be used to model systems not related to the spread of disease. For example, it can be used to model social contagion. Social contagion is something that is spread socially between people, such as ideas or hugs. The SIR model can be used to model social contagion within social media online and how ideas are diffused in general. One interesting example is how an applause is spread within an audience. At the right is a graph of how an applause is spread within an audience and the proportion of people. In informatics and technology, the SIR model can model peer-to-peer networks. It can model the spread of information throughout a network, and one such possible example is how many downloads a file has. Another use is the spread of a computer virus. It is analogous to a real-world disease, where computers are the primary population being modeled as infected. Thanks for watching our presentation on the SIR model. We hope it gave you a refreshing take on differential equations and mathematics as a whole. Feel free to check out the sources below for further information.